Today we will be in Chapter 10, Section 3, Graphing Linear Inequalities in Two Variables and Systems of Linear Inequalities. Our two topic objectives for today are to graph and/or identify the graph of a linear inequality in two variables and to solve systems of linear inequalities by graphing. Chapter 10, Section 3, Graphing Linear Inequalities in Two Variables and Systems of Linear Inequalities. That's a big mouthful. For basically, we're going to be doing Chapter 4.4, just basically with inequalities, and then you just finished in Chapter 9, systems of linear equations, but now we're going to do it with inequalities, and hopefully you see that it's really it's not a whole lot different, and this will just provide you with some extra practice. There's really only about 2 extra steps that you have to take in these problems. So the first thing to note is that if you're dealing with just greater than or just less than, like without the equals to part, and you're graphing those, you're going to be using a dashed line. And then if you are graphing inequalities that are greater than or equal to or less than or equal to, you're going to be using solid lines. So really, if it's the second case right here where it's the less than or equal to or the greater than or equal to, your graph is going to look exactly the same as a linear equation. And that's really what the next part says. It says graph the inequalities just like linear equations. The only additional thing you have to do is you're going to be doing some shading. And in that case, you have to pick a test point on each side of your line, and then you have to shade accordingly. And I know that doesn't really give you a lot of information, and that's going to make a lot more sense here in just a second whenever I can work through an example with you. So I'm going to slide it up a little bit. I'll leave this bottom stuff on there. And I'm going to write down an example, because really this is going to be the easiest way for you to understand what those last 2 lines say. Okay, our example says we have 9x plus 3y is greater than 6. Immediately, just looking at our sign or our symbol, we have a greater than. So we know immediately we're going to be doing dashed lines because that was the very first rule. And so I'm just noting that over to the side so that we remember it. If this was an equal sign right here, how would we go about trying to get this to where we could graph it? We'd need to get it into y equals mx plus b form, right? That's what we did in, 4.3, 4.4, and that's what we need to do here. We need to get this to look like y equals mx plus b. So let's get y by itself. We're going to subtract our 9x over to be 3y is greater than a negative 9x plus 6. Then we have to divide everything by a 3. So we get y is greater than negative 3x plus 2. Alright, we're going to graph this just as if this was an equal sign. So over here, if you want to pretend like this said y equals negative 3x plus 2. If this makes you more comfortable, just picture this for a second while we go to graph this, because the same mechanics work in this. Okay, so if we're graphing this, the first thing we need to look at is this plus 2 because that's our y-intercept. That means we're going to cross the y-axis at 0, positive 2. So that's our first point, is right there, 0, positive 2. And then we're going to use our slope. Our slope in this case is negative 3. So it means we go down 3, 1, 2, 3, and to the right 1 for our second point. That's exactly how we would be doing this if this was a linear equation. Now, instead of just connecting those 2 dots with, or 2 points With a solid line though, we already indicated we got to use a dashed line. So we're going to use a dashed line in this case. And the reason we're using a dashed line is because y is not actually going to fall on here. The answer to this linear inequality is not going to fall on this line. It's going to either be over here, which is why we're going to either shade over here, or it's going to be on this side and we'll shade on this side. But how do you know where to shade? This is where we're going to pick a test point. So it does not matter which side, and it does not matter which point, as long as we pick a point that's on that side. So right here we could pick the point 2, 2, because that's over here. And we could plug in 2 and 2 and work it out. But here's my hint. If 0, 0, use 0, 0 as a test point when possible. Because it's really easy to do the math with 0, 0. A lot of things go away. And notice our line did not go through the point 0, 0. So let's test that point. We have y is greater than a negative 3x plus 2. So if we're going to use 0, 0, we're going to plug in a 0 here and a 0 for our x. So then we get 0 is greater than a positive 2. Is that true? Is 0 greater than positive 2? No, this is false. And 0, 0 was over here on the left side of our line. So that means we're not going to shade that side. We're going to shade, if I find a marker that works, or highlighter, we're going to shade, can you guys see that? Yeah. We're going to shade to the right of our line. Okay. I wish you were here so I know if that would make sense. So I'm going to do another one. And I'm going to go ahead and draw. Okay, so there's my little Cartesian coordinate system, and my example is going to be y is less than or equal to a negative 1/2 x. So just based on my symbol right there, I'm going to be using a solid line. Now, what is my y-intercept? My y-intercept is 0, 0, because there's no, you can put plus 0 out there if you'd like, if that makes you more comfortable. So my initial point is going to be 0, 0. And then my slope is a negative 1 over 2. So I need to go down 1 and to the right 2. And plot my second point. This is going to be a solid line. Now, do I shade above the line over here, or do I shade below the line? We don't know. So we have to pick a test point. Now 0, 0 is on our line, so we can't test that one. But 1, 1 is not on our line, and that's an easy one. Again, you can pick whatever numbers you want, as long as they're not on this line, but I try to pick the easy ones. So I'm going to pick the 1, 1 spot. So it means where there's a y, I'm going to put in 1. And where there's an x, I'm going to put in 1. And I'm going to see if I get a true statement. So I get 1 is less than or equal to a negative 1/2 times 1 is negative 1/2. Is 1 less than or equal to a negative 1/2? No, that's false. So that means I'm going to shade below my line. And if you want further proof that that's actually the true, like where you're going to shade, pick a point down here and test it. So let's do -1, -1. If we did -1, -1, we would have -1 is less than or equal to a -1/2 times -1. So we'd have -1 is less than or equal to the -1/2 times the -1 would make that a +1. So is -1 less than or equal to a +1? Yes, this is true. But you don't have to do that. If you get a false on one side, there's only one other side to test. So that means you would automatically shade that side. So if you're just doing one inequality, you only have to really pick one test point. And if you get a true statement, you shade that side. If you get a false statement, you shade the opposite side. And that's how you do those. Now in the next bit that we're going to do, you will have to shade, or you will have to pick more than one test point in order to figure out what you're doing. Because now we're going to be doing systems of inequalities. If you didn't really grasp Chapter 9, I really recommend going back and doing that. Because this is exactly like Chapter 9, only with inequalities. So here's your example. You have y is less than -1/2 x plus 2, and you have y is greater than or equal to x minus 4. There's your system of linear inequalities. And we need to graph these. And I just showed you how to graph linear inequalities. So you could graph that top one, and then you just graph the second one. The shading is where it's going to get a little complicated. Now, if we're just looking at this top linear inequality, our symbol is just a less than, so that means we're going to be using a dashed line. And if you need to do notes over here like I'm doing, until you get used to doing that, I recommend it. And then we have our y-intercept, and we have our slope, so we should be able to graph this one fine. This bottom one, that's a greater than or equal to, so we're going to have a solid line. And then we have our y-intercept and our slope. So let me draw Cartesian coordinate system. Alright, so there's our Cartesian coordinate system. So we're going to do the first one. We get this y is less than a -1/2 x plus 2. That plus 2 is our y-intercept, so that means we're going to have a point at 0, 2. So that's going to be my first point, 0, 2, right there. And then I have a slope of -1/2, so I'm going to go down 1 and to the right 2, and I'm going to plot that other point. It's a dashed line, so when I connect my points, I need to make sure I use a dashed line. Oops. So there's a picture of our first inequality. Let's graph our second one. Our y-intercept for our second one would be 0, -4, because there's our b. So that's going to be our first point, 1, 2, 3, 4. And then I have a slope of +1. So I need to go up 1 and to the right 1. This one we're going to use a solid line because it's greater than or equal to. So there's our line. Now, how do we know where we need to shade? Well, we need to pick a point. But whenever we were just doing a single line, we only had to pick, 2. There's 2 spots that it could be. It could either be above the line or below the line. But if you look, we kind of have 4 sections. We have this section, and we have this section, and we have this section, and we have this section. So one of these 4 sections is going to get colored, but we don't know which one. So we need to pick a test point in one of these sections, and either we're going to luck out and we're going to get the true one the first time off, or we're not. And you never know. You could have to pick 4 test spots in order to figure it out. Again, I'm going to recommend if you don't use 0, 0, like if your lines don't hit 0, 0, let that be your first test point. Now, note, let me get down here to where I can make a note for you. Note, you must put the test point into both inequalities. Okay, I'm going to write my inequalities down here again. Y is less than negative 1/2 x plus 2. Y is greater than or equal to x minus 4. So those are our 2 inequalities. And again, I'm going to start with 0, 0. That's going to be my test point, and I'm going to see if that one works. So I'm going to test 0, 0 first. And hopefully it works out and it's true. So we need to plug in 0, 0 in our first inequality. So we have 0 is less than negative 1/2 times 0 plus 2. 0 is less than 2. Is that true? That is true. So hopefully our next one is true, and then we know which one to shade. We have 0 is less or greater than or equal to 0 minus 4. So 0 is greater than or equal to negative 4. Look at that, we lucked out. That is a true statement. So right there, we know that whichever part the 0, 0 is in, that's where we're shading. So that means we would only shade that section. Just notice the yellow might be hard to see, so that section. Okay, we're going to do another one because I know this is a little bit weird. So let me get you another problem. We have example. We have 3x minus y is less than 6, and we have 2x plus 2y is greater than or equal to 5. Okay, just like when you're solving linear equalities, or linear equations, you need to get these to look like y equals mx plus b, so we need to get our y by itself, okay? So I'm going to deal with just the one on the left first. I'm going to subtract over my 3x, so I have negative y is less than negative 3x plus 6. I need that negative to go away, so I'm going to divide by it. But remember, when you divide by a negative across an inequality, it flips your sign. So that's going to be greater than, and then it's going to be a positive 3x minus 6. So don't forget to flip your sign. That'll be the first thing. Now this looks like y equals mx plus b. So just based on our symbol, we know this is going to be a dashed line. We know that our y-intercept, do we know what that is? Yeah, it's 0, negative 6. And we know our slope is 3. So we know all of that information already. Let's go deal with this one. We need to get y by itself, so I'm going to subtract over my 2x. That'll give me 2y is greater than or equal to negative 2x plus 5. We didn't have to flip the sign because we were subtracting, not dividing or multiplying. We do need to divide by this positive 2, and so it's going to be y is greater than or equal to a negative x plus 5 over 2. So based on our symbol, we know this is going to be a solid line, and we know that our y-intercept is 0, 5 halves, and we know our slope is a negative 1. So let me get our graph done up. Okay, so there's our Cartesian coordinate system. And if we're dealing with the one on the left, we know our y-intercept is 0, negative 6, which will be right here. Oops, right there. And our slope is a positive 3. That means we go up 3, 1, 2, 3, and over 1. When we connect these 2 points, we have to remember it's a dashed line. So there's the first one. Now for our second one, we have 0 and 5 over 2. Remember, 5 over 2 is 2 and 1/2. So it means we're going to go up 2 and then hit a half and put our point right there. And then our slope is a negative 1, so we go down 1 and to the right 1. And that's going to be a solid line. So there's our second line. Now we just need to know where we're going to do our shading. Again, we have 4 parts that we could shade. We could shade this part, this part, this part, or this part. And again, I'm going to recommend doing 0, 0 first. So I'm going to rewrite our equations down here real quick, or inequalities. Alright, so there we go. And we're going to test out the point 0, 0. So if we're testing out 0, 0, we're going to put 0 in for both of them. So we get 0 is greater than negative 6. Is that true? Yes, it is. So that's true. Now let's go over here. We have 0 is greater than or equal to 0 plus 5 over 2. So 0 is greater than or equal to 5 halves. Is that true? No, that's false. Okay, so what does that tell us? That tells us that where 0, 0 is right here, we are not going to shade in this area. That area is going to remain open. But I will tell you one thing. The fact that it was true for our dashed line means that it's going to be on this side of our dashed line, because it held true. That 0, 0 held true for our dashed line, which means that it should be this section right here that we color in. Okay, I'm going to put a little X in this section, which means we're not going to color that one in. Let's pick a point in this section and see if it holds true. So I'm going to pick something right on the y-axis, because that's going to give us a 0 for something. So this is point 1, 2, 3. So I'm going to do the point 0, 3 as my next test point. Again, you can do whichever number you want, but that's going to be the one that I'm going to test next. So let's come down here. Sorry, I'm trying to keep my paper straight for you. Then let's test 0, 3. So where there's a y, we're going to plug in 0, which is greater than 3 times, or excuse me, where there's a y, we're going to do 3. And 3 times 0 minus 6. So we get 3 is greater than a negative 6. That's a true statement, which is good. And then over here, we're going to have a 3 for our y, and then a 0 for our x. So we get 3 is greater than or equal to 5 halves. Is that true? Yes, it is. So once you get 2 true statements for 1 point, that tells you where you're shading. So we're shading this area right up here. Okay, I'm going to do at least 2 of your homework problems with you so that you can see how to graph inequalities using Course Compass and how to use the shading and all of that jazz. So let's go on to that. Okay, so once you get your homework open for section 10.3, I'm going to work with you number 1 and number 7. There's only 8 questions for this whole homework assignment. So remember, if you need extra practice doing it, there will be a similar exercise button down here once you complete a problem, and you can keep clicking that as many times as you'd like. So number 1 says graph the inequality x is greater than negative 6. So just based on the sign, we know it's going to be a dashed line. And if you think about, let me pull up my note page real quick. If you remember back to chapter 4, when we had x equals negative 6, that told us that we had a vertical line at x equals negative 6. So similarly, we're going to have a vertical line in this case. It's just going to be a dashed line. Okay? So we're going to do that, and then we're going to have to test a point. So let's click to enlarge the graph. And over here on our line tool, you're going to still select that, but then if you go down right here, you can make the selected object dashed, which is what you want to do. So click that, and it's going to let it be a dashed line. So it says x is greater than negative 6, so we need to go over to x is negative 6 and graph a vertical line there. And right there you see they made it into a dashed line. Now we need to know which side we're going to shade on. So I'm going to go back to my notes page, and I have the equation is x is greater than negative 6. Like I told you, I will always use the point 0, 0 as my test point if I can. So 0, 0, I need to plug in 0 for my x and my y. There's no y in this case, so I just put in 0 for my x. And that says 0 is greater than negative 6. Is that a true statement? Yes, it is. That's true. So I need to shade the part that has the 0, 0 point. So let's go back to the homework. Alright, so my 0, 0 point is right here, so I need to shade this part. So I need to grab this bucket, my shading tool, and then I need to click over here to the right of my dashed line. And as you notice, it turns it yellow. I need to save that, and then I need to check my answer. We got it right. Let's do number 7. Number 7 is going to be a system of inequalities. And luckily, it's already written in the form that we like to see it, in the y equals mx plus b form. So that means we'll be able to graph without having to do any additional math. So I'm going to enlarge my graph. Now, if we're looking at just this top one, y is less than 3x minus 3. That less than sign means we're going to use a dashed line. So I'm going to click my line tool, and then I'm going to make sure it's marked dashed. The -3 tells me my y-intercept is down at -3, so I'm going to go down there and put that as my first point. And then the slope for that top equation is +3, so I have to go up 3, 1, 2, 3, and to the right 1, and then I'm going to plot that point. So right there is the graph of my first line. Now I need to plot my second line. So I click my line tool again, make sure that my line is solid. And then I'm going to graph. My y-intercept in this case is a +3, so I go up to +3, and my slope is -2, just -2. So I go down 2 and to the right 1, and click that. Again, I have 4 spots that I could shade. So I'm going to pick 0, 0 as my test point, and I'm going to try that one out. So let's write down our 2 lines. We have y is less than 3x minus 3, and y is less than or equal to -2x plus 3. And I'm going to use my test point as 0, 0. So I have to plug that in both of my inequalities. So I get 0 is less than 3 times 0 minus 3. So 0 is less than -3. Is that a true statement? Is 0 less than -3? No, that's false. So already we know that that's a bad test point. So let's pick a different test point. We know that it's not over here. So let's pick a point right here. Let's pick 1, 3. Let's test that one out. And I mean, I'm just guessing. I don't know which one of these is going to work. So let's do 1, 3. Y is less than 3x minus 3. So I'd have to put a 1 in for my x's and a 3 in for my y's. So I have 3 is less than 3 times 1 minus 3. So 3 is less than 0. Is 3 less than 0? Nope. Okay, so since that's a false, we know that it's not that section. So let's come over here and let's pick a point. Let's just pick the point right here. Let's pick 2, 0. That's a good one to test. It's on the x-axis. So that means one of ours will be 0, which makes plugging it in a little bit easier. So again, we have y is less than 3 times x, minus 3. Wherever there's a y, I'm going to have 0. And wherever there's an x, I'm going to have 2. So I have 0 is less than 6 minus 3. So I have 0 is less than 3. Finally, we get a true statement. So that's good. But we still have to plug it into our other inequality, which is y is less than or equal to 2x plus 3. So wherever there's a y, I'm putting in 0. Wherever there's an x, I'm putting in 3. So we get 0 is less than or equal to -6 plus 3. 0 is less than or equal to a -3. That's not true. So that's false. But luckily, we've tested 3 out of the 4 sections. We tested this one, and that was false, and this one was false. So that leaves this one. So maximum, you have to test 3 sections before you know which one's true. So we shade that one. Let's check our answer. We got it right. So there's another one like that. Number 8 is another systems of inequalities where you have to plot them and then shade them. Please, please, please use this similar exercise button so that you get some extra practice on these. So good luck on your homework and good luck on your quizzes.